at Suffolk Machinery Corp. are proud to present our fine selection of products. In the video you are about to watch, we will show and demonstrate the following products: Timberwolf band mill blades, dual tooth setter, urethane V-belts, blade guides, Ruby and CBN grinding wheels, clamp-on set gauge, Starrett blade protractor, and educational video.
We have been manufacturing band mill blades since 1989, using exclusively Swedish silicon steel and the most advanced manufacturing processes in the industry. Silicon steel has a low-carbon, high silicon content that gives us the longest overall flex life of any band mill blade on the market. We make over 20 different variations of our 1 1/4 inch, 1 1/2 inch, and 2 inch blades to match the mill you are using and the wood you are cutting. We are the only blade manufacturer that sets the same blade differently depending on whether you are cutting hardwood, softwood, frozen wood, exotics, or recycled timber. The quality of our steel is so high that our blades require 30 to 40% less tension or strain to run properly. For example, if a mill manufacturer suggests running 2,300 to 2,500 pounds of hydraulic pressure, our blades will run on that machine at 1,500 to 1,900 pounds. If your mill is not equipped with a gauge to indicate tension, we have a very specific test that can be run to find proper tension for our blades on your mill. Running lower strain on the blade is not only good for the blade, but also increases wheel bearing and shaft life. Running lower strain also uses fewer horsepower to turn the blade, which in turn reduces fuel consumption. We mill the teeth into our blades and induction harden the tooth edge, as opposed to stamping the teeth and flame hardening, which is the most common method used by our competitors. Using silicon steel and induction hardening allows us to harden the tooth edge of our blades to 67 Rockwell, versus high-carbon blades that can only be hardened to 59 Rockwell. This in turn gives us a harder edge that will stay sharper for a longer period of time, each time you use the blade. We don't, however, harden the body of the blade to the same degree as some manufacturers do. Hardening the body of the blade is as important as the hardening of the tooth. If the body of the blade is hardened to the same degree as the tooth edge, this can result in reduced flex life or spin life. If our blades are run and sharpened properly, you should average from 8 to 12 sharpenings per blade. These blades, although more expensive than other common blades, will produce 2 to 3 times the amount of lumber and will reduce your overall blade cost dramatically. Our dual tooth setter is very unique in the industry. This unit is an industrial setter scaled down for individual use. It is capable of upsetting and downsetting teeth. It sets 2 teeth at a time from both sides of the blade using 2 sets of tool bits. Other setters presently available cannot match the speed and accuracy of this machine. To operate this machine, we first place the blade in the setter by bringing the clamping handle to its upright position and then sliding the blade down between the clamp plates. The thumb screws at either end of the machine are independently adjusted for proper tooth height. A gauge block is provided to achieve the proper height, which is 160 thousandths of the tooth above the clamp plates, or about half of the tooth. By setting only half the height of the tooth, you will gain 15% faster feed rates and create 40% less gullet strain, which allows for more overall sharpening and settings. Once the proper tooth height is achieved, you can begin adjusting the tool bits. Pushing the clamp handle down towards the floor, the clamp plates apply 500 pounds of force to the body of the blade. With the clamp handle at the bottom of its stroke, the upsetting tool bits are adjusted inward. Once adjusted, these tool bits contact the teeth on either side of the blade with another 350 pounds of force. Next, the downsetting tool bits are adjusted. The downsetting tool bits act as a stop while upsetting a blade and will push set out of any tooth that is beyond the desired set point. The same downsetting tool bits can be used independently to remove set from the teeth around the whole blade. The tool bits are independent and, when adjusted properly, will set the teeth to within 2 thousandths per side. Next, we bring the setting handle back up to its highest point and pull the advance lever back and then forward until it stops. This action brings the next set of teeth into position. This handle can adjust from 1/2 inch to 1 1/4 inch pitch blades. The width of the setting tool bits allows you to set from 1/2 to 1 inch pitch without having to make any changes to the lateral position of the setting tool bits. If the tooth spacing is longer than 1 inch, the tooling modules must be adjusted. We also supply a clamp on the set gauge to check the set of the teeth. This tool is used when adjusting the tool bits to achieve different amounts of set during setup of the machine and periodically while setting the blade. Loading, adjusting, and setting of a blade can be performed in less than 5 minutes on a blade of 14 feet. Once the machine is set for a specific type of blade, the setting of the blade will only take about 2 to 3 minutes. There are a number of advantages this machine has to offer. The two most important are the amount of clamping force it applies to the body of the blade, and that even pressure is applied to the teeth on both sides of the blade simultaneously. Other setters on the market cannot apply nearly enough pressure needed to ensure that your blade is positioned identically each time you set a tooth. Even though you might read 21 thousandths on your dial indicator, you have to take into account that there might be 1 thousandths or 2 thousandths difference in the clamping of the blade. This unit will quickly pay for itself as opposed to using a single tooth setter that will normally take you 15 to 20 minutes to set one blade. The time you will save is somewhere between 15 and 18 minutes per blade. After the first 100 blades, you will have saved 1,500 minutes or 25 hours, and you will not dread the thought of having to set your blades. If you figure the time saved and your hourly worth being conservative at $20 per hour, you could have made $500 sawing lumber in the time you saved by using this machine. This unit weighs 50 pounds and comes with a 22-page instructional manual. Urethane is an amazing polymer that has excellent load-bearing and shock-absorbing qualities and is super resistant to wear. It is ideal for use on band wheels running V-belts. There are many advantages to using urethane over rubber. The urethane V-belts are tight-fitting, which eliminates 70% of the vibration in the head of the mill that is caused by running loose V-belts. They also eliminate any buildup of sawdust on and under the V-belt. The urethane absorbs 50% more shock when the blade is stressed in the cut compared to rubber V-belts. The patented grooves literally suck the sawdust off the inside of the blade, which eliminates any inconsistency with tension on the blade. Nothing will stick to our urethane V-belts, which eliminates any need for cleaning or scraping of your band wheels. They will last 4 to 5 times longer than a standard automotive V-belt. If you own a mill that runs steel wheels without any rubber tires or V-belts, we can also provide you with V-belts to fit your machine. Making this change will dramatically increase the life of your blades, reduce the horrendous noise made when running steel on steel, and eliminate the need for scrapers on your wheels. It is recommended that you machine steel wheels after every 750 hours of use. If you decide to use our urethane V-belts, you will only have to machine your wheels once to make these belts fit, and never have to machine them again. If you own a mill that drives one band wheel directly from the motor, we can provide you with one V-belt for your idle wheel. Unlike most guide systems on band mills that only support the top and back of the blade, our guide systems support the blade from the top, the bottom, and the back. Our systems incorporate 2 bearings to support the top of the blade, 1 bearing to support the back of the blade that runs on the same axis as the blade, and a bronze oil-impregnated pad to support the bottom of the blade. Using a bearing to support the back of the blade as opposed to a flange, which most mills use, eliminates about 50% of the heat that is generated when the blade rides back against the flange. The reason for the heat reduction is the elimination of friction that is caused when the flange actually scrapes the back of the blade, as opposed to rolling with the blade. Unlike the roller on a conventional guide that rolls with the top of the blade, the flange is traveling in the same direction as the roller, but not the same direction as the back of the blade. The oil-impregnated bronze insert that sits 0.005 of an inch below the bottom of the blade has a number of functions. It restricts the blade from traveling downward in the cut when the blade is deflected by a knot or pocket of stress in the log. It is self-lubricating and highly resistant to wear. It will also help to keep the bottom of the blade clean as the blade periodically rubs against the surface of the insert. The oiler releases lubrication in a much more controlled manner than common guide systems. Fluid is released at the front and back of the blade, 15 thousandths of an inch above the top of the blade. This allows almost all of the lubricant to stay on the blade as it enters the cut, as opposed to just releasing the fluid through a tube above the blade. This guide system will increase the quality of your lumber and give you more confidence sawing through species that are more difficult to cut. We make them to fit the Wood-Mizer, Baker, AccuTrack mills, as well as 1999 and early Norwood mills. But this guide system can be adapted to fit almost any mill.
CBN, or cubic boron nitride, is a superabrasive material that is comparable to diamond in hardness and heat conductivity. To make a grinding wheel, the CBN material is electroplated to a preformed shape that matches any one of 4 Timberwolf tooth profiles. These wheels never have to be dressed or shaped and can be returned for replating when needed. CBN wheels will produce a 50% sharper tooth than conventional aluminum oxide grinding wheels and can last up to 15 times longer. Our CBN wheels are made of the highest quality abrasive material available and will outlast standard CBN grinding wheels by up to 3 times. Our CBN grinding wheels are available in 5 and 6 inch diameters and are designed to be used on dedicated oil-cooled grinders only. We stock both 5 1/4 and 6 inch by 3/8 thick ruby grinding wheels that are designed to run on conventional wet and dry grinders. These ruby wheels cut much cooler and cleaner than standard aluminum oxide wheels and last twice as long as the blue ceramic grinding wheels. This tool is used to measure the amount of side clearance or set in the teeth of a 1 to 2 inch wide blade. To use the set gauge, we first zero the tool to the body of the blade by tightening the clamp and then adjusting the dial indicator to 0. We then loosen and move the tool up to the tooth that is to be checked and again tighten the clamp to the body of the blade. The dial indicator will read how far the tooth is offset from the body of the blade. A blade must be set to within 3/1000ths from side to side to cut effectively. This tool will allow you to check that your new or used blades are set accurately and set correctly for the species you are cutting. The set gauge is included with the purchase of our dual tooth setter or can be purchased separately. This tool is specifically designed to measure the hook or cutting face angle of the tooth of a blade. It is used by sliding the protractor base up until it meets the back of the blade and then pivoting the protractor arm until it matches the angle at the top half of the tooth. This is a precision-made tool that is accurate to within 1/2 of a degree. The cutting face angle of the tooth is a critical component of the blade and must be properly maintained to achieve quality cuts. This tool will allow you to check both new and used blades for accuracy of the hook angle and consistency throughout the blade.
No matter whose blades you are using, this information will make you money. This is the first educational video produced that fully explains the proper use and articulation of band mill blades. Through animation and real-time footage, it gives you an in-depth description of each blade component and its function. We guarantee that this is your guide to becoming the most productive sawyer you can be, or your money back.